This is the EdExcel GCSE 9-1 Maths Paper 3 from the Foundation Papers, and it's from the 2018 series. Question number 1. We have to write 9/10 as a decimal. If we type in 9/10 as a fraction into our calculator and then press equals and then press STD, our calculator displays for us the decimal 0.9. Question number 2, we have to write 0.3 as a percentage. Well, to convert 0.3 to a percentage, we take the 0.3 and then we multiply this by 100. And doing so, we end up with 30%. Question number 3, we have to write the number 2538 correct to the nearest 100. Well, if we draw a number line, if we round to the nearest 100, well, we will either round the number down to 2500 or round the number up to 2600. And we've got our halfway point, 2550. Now, if we mark on our number over here, 2538, we can see this is less than 2550, and so what we would have to do is round down to the 2500. Question number 4. Here are the first 4 terms of a sequence. We've got 2, 9, 16 and 23. For the first part of part A, we have to write down the next term in the sequence. Well, do you notice from each term we add on 7 each time? So if I add 7 to 23, we get 30. So the next term is 30. And then, explaining how we got our answer, we add 7 to the previous term to get the next term. And then for part B, we have to work out the 10th term of the sequence. Well, something plus 7 gives 2. And that something then is -5. And so the nth term then will be 7n subtract 5. And therefore, when n is 10, so the n equals 10 is because we are working out the 10th term, we have 7 times by 10 subtract 5, which is 65. So the 10th term is 65. Question number 5. Here are 4 digits, 7, 3, 4 and 9. For part A, we have to put 3 of these digits to write down the largest possible 3-digit number. Well, if we want to write down the largest possible 3-digit number, our number needs to begin with a 9. So we've used up the 9. Then the next digit will be the 7, and then the digit after this will be the 4. So we have 974. And then for part B, here are 4 different digits. We've got 8, 2, 1 and 6. We have to put one of these digits in each box to give the smallest possible answer to the sum. You must use each digit only once. Well, we want to make the smallest possible sum. So for these 2-digit numbers, we want to use the smallest numbers possible. So I need to start off with the 1, and then I need to also start off with the 2 over here. Now, if I have the 8 over here and then the 6 over here, what is this sum? Well, 18 plus 26, that's 44. But what would happen if I have the 6 here and the 8 over here? Well, in that case, I still get 44. So, question number 6, we have to write down all the factors of 30. 1 times 30 gives 30. 2 times 15 gives 30. 3 times by 10 gives 30. 5 times by 6 gives 30. Here are all the factors of 30. Question number 7. David has twice as many cousins as Becky. Becky has twice as many cousins as Nishat. Nishat has 6 cousins. How many cousins does David have? So we have n, which is equal to 6. We are told in the question n is 6. Then we are told Becky has twice as many cousins as Nishat. So Ben is 2n. So we have 2 times by 6, which is 12. And then David has twice as many cousins as Becky. So 2 times by Becky, 2 times by 12 is 24. Question number 8. For part A, we have to find the value of the square root of 1.44 times 3.61. So if we input this into our calculator, we get 2.28. For part B, we have to find the value of 3.54 subtract 0.96 all squared, subtract 4.096. Well, let's type this into our calculator. We open up the bracket, we type in 3.54, then we have subtract, then we have the 0.96, close bracket, then squared, subtract 4.096. And it turns out in this case, we get 2.5604. Question number 9. This is part of a bus timetable between Bury and Manchester. For part A, how many minutes should the 8:25 bus take to go from Bury to Manchester? Well, if we take a look, we've got the 8:25 bus. This is from Bury. And then, when it arrives in Manchester, the time it arrives in Manchester is 09:05. And what we have to do in this question is find out how long it takes 8:25 to 9:05. This is equal to 40 minutes. Then Daniel goes from Whitefield to Manchester by bus. Daniel takes 17 minutes to get from his house to the bus stop in Whitefield. He then takes 15 minutes to get from the bus stop in Manchester to work. Daniel has to get to work by 10 AM. He leaves his house at 8:45 AM. For part B, does Daniel get to work by 10 AM? You must show all your working. So, we know from the question, he leaves at 8:45 AM. And then we add on 17 minutes, which we know is the time for him to get to his house to the bus stop in Whitefield. Then, if we work out what time he would arrive at the bus stop in Whitefield, this will be 9:02 AM. So he arrives at the bus stop in Whitefield at 9:02 AM. So if that's the case, then if we arrive at 9:02 AM, we should catch the 9:04 bus, and if we catch the 9:04 bus, we arrive to work at 9:35 AM. So if we arrive at Manchester at 9:35 AM, what we need to do now is add on the 15 minutes, which is the time it takes for him to go from the bus stop in Manchester to work. So if we work this out, we end up with 9:50 AM. So the 9:50 AM is the time he arrives at work. Now, we are told in this question, well, we want to find out if he gets to work by 10 AM. And therefore, because we arrive at 9:50 AM, he gets to work on time. Question number 10. Bronwyn works in a restaurant. The table gives her rate of pay. So Monday to Friday, the rate of pay is £8.40 per hour, and on a weekend it's £11.20 per hour. Bronwyn worked for a total of 20 hours last week. She worked 8 of these 20 hours at the weekend. We have to show that Bronwyn was paid less than £200 last week. Well, first of all, if she worked 8 of these 20 hours at the weekend, that means 20 take away 8 is 12 hours, which is worked on a weekday. So now we need to find out the pay for this. So the pay, well, we are working 12 hours, and Monday to Friday, we are paid £8.40 per hour. So this is the amount we are paid on a week day. And then on a weekend, we are working 8 hours on the weekend, and we are paid £11.20. So this is the weekend pay. So 12 times 840 plus 8 times 1120. This is £190.40. And this amount is less than the £200. That's exactly what we wanted to show. Question number 11. Last year the cost of a season ticket for a football club was £560. This year the cost of a season ticket for the club has been increased to £600, we have to write down the increase in the cost of a season ticket as a fraction of last year's cost. Well, first of all, we need to find the increase. The increase, that's equal to 600 subtract 560, which is 40. So what we need to do is write down the increase in the cost of a season ticket as a fraction of last year's cost. Well, this is the increase, that's 40, and then last year's cost, we are told that is £560. So we have 40 divided by 560, and if we work this out, it turns out we get 1 over 14. So the fraction then is 1 over 14. Question number 12. The diagram shows a scale drawing of a tennis court. The scale of the drawing is 1 to 200. We have to work out the perimeter of the real tennis court. Give your answer in meters. Well, here is the width 5.6 centimeters and here is the length 11.4 centimeters. So the perimeter of the scale drawing, we have 2 times by 11.4 plus 2 times by 5.6. So if we work this out, what we end up with is 34 centimeters. And therefore, the perimeter of the real tennis court, that will be 34 multiplied by the 200. And if we work this out, we get 6,800 centimeters. And if we work out what this is in meters, I would have to divide by 1,000, so I get 6.8 meters. And just to emphasize, what we did was we divided by 1,000. Question number 13. Here are 6 straight line graphs. We've got graph A, B, C, D, E and F, and we have to match each equation in the table to the correct graph. We have to write the letter of each graph in the table. Well, y equals 2, that's going to be a horizontal line crossing the point 2, so that's graph D. Y equals x, that's graph F, it passes through the origin. And x plus y equals 2. Well, when x is 0, 0 plus y is 2, which means y is 2. And when y is 0, x plus 0 is 2, which means x is 2. That would correspond to graph A. Question number 14. Here are the marks 20 students got in a French test. For part A, we have to show this information in a stem and leaf diagram. So we've got numbers in the 70s, the 80s, the 60s, the 90s, and the 2-digit numbers. So we've got numbers in the 60s, 70s, 80s, and 90s. And let's cross these off as we're going along. Now, the smallest one is this 64. So we have 64. Then the next smallest one in the 60s is the 67. So then we write down 7 here, and then we have 69, which is over here, and then we have another 69 over here. And then we have in the 70s, the smallest one is this 70. So we can cross that off. So here we've got 70. And then we've got another 70 over here. So let's write down another 0. Then we've got the next smallest one, which is this 71. So we cross off this 71. And then we've got the next smallest number, which is 75. So the 5 goes here. And then after that, we've got the 76, which goes here. So let's cross off the 76. And then we've got another 76 here. And then we've got a 77 here. So we cross off this 77. Now in the 80s, well, we've got 80. So we put a 0 here. Then we've got another 80. So we have another 0 here. Then we've got 81 here, and we've got another 81 here, so that's 81 twice. And then we've got the 82. Then we've got the 84. And then we've got the 87. And then with the 90s, well, we've just got 91 and 94. So we've got 91 and 94. Now what we need to do is create a key. So with our key, we've got the 6 and then the 4, which means 64 marks. Then for the next part of the question, one of these students is going to be chosen at random. The pass mark in the French test is 71. Omar writes the probability that the student failed the French test is a quarter. Omar is wrong. We have to explain why. So the pass mark is 71, which means 1, 2, 3, 4, 5, 6 of them scored lower than 71. In other words, 6 failed the test. So therefore, the probability that this student failed the test, well, we have 6 out of 20 students in total. And if I work out 6 over 20, we get 3/10, and this does not equal the 1/4. So this is why the student Omar is wrong. So Omar is wrong. Question number 15. Jenny is asked to find the value of 12 subtract 2 times 4. Here is her working. She did 12 take away 2 times 4 is 10 times 4, which is 40. So they did the 12 take away 2 first. And Jenny's answer is wrong. Explain what Jenny has done wrong. Well, we were supposed to do the 2 times 4 first, which is 8, and then do the 12 take away the 8, which is 4. So she used bit mass incorrectly. And then for the next part of the question, Ruhan is asked to find the range of the numbers 3, 1, 8, 7, 5. Here is his working. He did 5 take away 3, which is 2. This is wrong. Explain why. Well, to work out the range, we need to do the biggest take away the smallest. Now, the biggest number is 8. The smallest number is 1. So the range is 7. Question number 16. Alan, Bispa and Chan share a sum of money. Alan gets 1/8 of the money. Bispa gets half of the money. Chan gets rest of the money. Alan gets £2.50. We have to work how much money Bispa gets. Well, if we let the total amount of money equal X, then we know that Alan gets £2.50 and Alan gets 1/8 of the money. So, if we focus on Alan, we've got 1/8 of X, that's equal to £2.50. So I can find out what X is by multiplying by 8 to find out the total amount of money. 8 times £2.50, that's going to equal £20. So we've got £20 in total. Now, we know that Bispa gets half of the money. So Bispa, she would get 1/2 of 20, which is 10. So, therefore, Bispa would get £10. Then for part B, we have to find the ratio of the amount of money Alan gets to the amount Chan gets in the form A to B, where A and B are whole numbers. Well, let's find out how much Chan gets. Chan would get, well, there's £20 in total. We take away the £2.50 which Alan gets, and then the 10 that Bispa gets. It turns out Chan would get £7.50. And therefore, the ratio of the amount of money Alan gets to Chen gets, that's equal to £2.50 to £7.50. And it turns out this simplifies to 1 to 3, and the way we got that was we divided both sides by £2.50. Question number 17. ABC is an isosceles right-angled triangle. We've got 3x and 3x here. The area of the triangle is 162 centimeters squared, and we have to work out the value of x. Well, to work out the area of a triangle, we do 1/2 times by the base, which is 3x, times by the height, which is 3x. So it turns out we get 9x squared divided by 2, and this is equal to 162. So to find out what x is, well, let's multiply both sides by 2. So 162 times 2, that's 324. So I've got 324, which is equal to 9x squared. And then if I divide both sides by 9, 324 divided by 9 is 36. So 36 is equal to x squared, and therefore x is equal to 6. Question number 18, we have to work out the value of 2.645 times 10 to the 9 divided by 1.15 times 10 to the 3. We have to give our answer in standard form. Well, you'll recall for standard form, that's when a number is written as a times by 10 to the power of n, where a is in between 1 and 10, but not including 10. So, if I type this in, I've got 2.645 times 10 to the 9 divided by 1.15 times 10 to the 3. So it turns out we get a value of 2,300,000. Now, if the decimal point is here, we need to move this decimal point 1, 2, 3, 4, 5, 6 to the left. So I've got 2.3 times 10 to the 6. So we've got 2.3 times 10 to the 6. Question number 19. The scatter diagram shows information about 12 girls. It shows the age of each girl and the best time she takes to run 100 meters. So we've got the time in seconds and the age in years. For part A, we have to write down the type of correlation. Well, what we can see is as the age increases, the time decreases, and therefore we have a negative correlation. Then for the next part, Christina is 11 years old. Her best time to run 100 meters is 12 seconds. The point representing this information would be an outlier on the scatter diagram. Explain why. Well, 11 years old and 12 seconds. If I plot that, that would go over here. And the reason this point is an outlier is, well, if I take a look at all the points and then this one, what we can see is this point doesn't follow the general trend of other points. Now, for the next part, Debbie is 15 years old, and Debbie says, the scatter diagram shows I should take less than 12 seconds to run 100 meters, and we have to comment on what Debbie says. Well, 15 years old, if I draw a line of best fit to begin with, something looking like this, then what we can see is, taking a look at the data I've got so far, 15 years old is outside of the range of data values given. So 15 years old is outside of the data values given, so we cannot be certain. Question number 20, we have to expand and simplify 5 multiplied by p plus 3, subtract 2 multiplied by 1, subtract 2p. 5 times by p is 5p, 5 times by 3 is 15, minus 2 times 1 is minus 2, minus 2 times minus 2p is positive 4p. So if we work out all of this, it turns out we would get 9p plus 13. Question number 21. Here is a trapezium drawn on a centimetre grid, and what we have to do is on the grid draw a triangle equal to this area of the trapezium. Well, what we see here is we've got 2 centimetres this way. We have 4 centimetres for the height. And this side is 7 centimetres. So we can find out the area of the trapezium. The area of the trapezium, we've got 1/2 times the sum of the 2 parallel sides, 2 plus 7, times by 4. So it turns out we would get 18 centimetres squared, which means the area of the triangle is equal to 18 centimetres squared. So what we need are 2 numbers such that when we multiply them by 1/2 we get 18. So what we could have, for example, is 1/2 times 6 times 6, which is equal to 18. So we want a triangle with dimensions 6 centimetres by 6 centimetres. So if I draw that, here is our triangle. We have a height of 6 and a base of 6. Question number 22. When a biased 6-sided dice is thrown once, the probability that it will land on 4 is 0.65. The biased dice is thrown twice. Amir draws this probability tree diagram. The diagram is not correct. We have to write down 2 things that are wrong with the probability tree diagram. Well, if the probability that we land on a 4 is 0.65, that means the probability that we do not land on a 4 is 1 subtract 0.65, which is 0.35, not this 0.25. And now, the other thing that's wrong is, if on our second throw, if we land on a 4, then the probability that we land on a 4 should be 0.65, not this 0.35 over here. Question number 23. ABC is a right angle triangle. We've got AB being 11 centimetres and BC being 7 centimetres. We have to work out the size of the angle ABC correct to 1 decimal place. Well, we've got to work out this angle here. We've been given the hypotenuse and the adjacent, and so therefore the cosine of the angle ABC is equal to 7 divided by 11. So the angle ABC, that's equal to the inverse cosine of 7 over 11. So if we work out what this is, then we get 50.47 etc. degrees. So to 1 decimal place we have 50.5 degrees. Now for part B, the length of the side AB is reduced by 1 centimetre and the length of the side BC is still 7 centimetres. the angle ABC is still 90 degrees, will the value of cos ABC increase or decrease? You must give a reason for your answer. Well, if we reduce this by 1 centimeter, AB is now 10 centimeters. So AB is equal to 10 centimeters. And so if we were to work out the cosine of ABC, we would have this time 7 over 10. And the 7 over 10, this is greater than the 7 over 11 which we got before. And so therefore, the cosine of ABC would increase. Question number 24. There are some counters in a bag. The counters are red or white or blue or yellow. Bob is going to take at random a counter from the bag. The table shows each of the probabilities that the counter will be blue or will be yellow, and there are 18 blue counters in the bag. The probability that the counter Bob will take will be red is twice the probability that the counter will be white. What we have to do for party is work out the number of red counters in the bag. Well, if we say that the probability of obtaining a white is x, that means for red that's twice this, so that's 2x. So we have 2x plus x plus 0.45 plus 0.25. This is equal to 1. So we have 3x plus 0.7 equals 1. So 3x is 0.3, which means x is 0.1. So therefore, we've got 0.1 over here and 0.2, which is twice 0.1 for the probability of red. So the probability of obtaining a red is 0.2. So now what we need to do is work out the number of red counters in the bag. Well, we know that we've got 18 blue counters. So if we've got 18 counters, this is represented by a probability of 0.45. That's the probability of blue. So what we need to do is find out how many is represented by a probability of 0.2. Well, what we can do is find out how many counters are represented by a probability of 0.05 and then the probability of 0.2. So here we divide by 9 to get 2 counters, and then if I times by 4, we get 8 counters. So we have 8 counters. Then for the next part of the question, a marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. There must be an even number of marbles in the box. Explain why. Well, here, half the marbles must be silver for the probability of silver being 0.5, which means we must have an odd number of marbles. And that's because if we had half the marbles must be silver for the probability of silver being 0.5. So odd number of marbles means odd divided by 2 won't give a whole number of marbles, which means we must have an even number of marbles. Question number 25, we have to solve 5 minus x over 2 equals 2x minus 7. Well, if we multiply both sides by 2, then on the left hand side we are left with 5 minus x, and on the right hand side we have 2 multiplied by 2x minus 7. So we have 5 minus x equals 4x minus 14, and if we rearrange, well, what we can do is add x to both sides. So we have 5 equals 5x minus 14, and if I add 14 to both sides, that means 5x is equal to 19, and if we divide both sides by 5, that means x is equal to 19 over 5. So we have x is equal to 19 over 5. Question number 26. ABCDE is a pentagon, and we are told that the angle BCD is twice the angle ABC, and we have to work out the size of the angle BCD. You must show all of your working. Well, first of all, we can find the sum of the interior angles in a pentagon. What this is equal to is 5 subtract 2. We've got 5 sides, so take away 2 and then times by 180. It turns out we get 540 for the sum of the interior angles. So all of the angles inside here add up to 540. Now, if we say that this angle here is x, then the angle here must equal 2x, because we are told that the size of the angle BCD is twice the angle ABC. So we have 2x plus x plus, now here we've got 90, and then we add on 115, and we've also got the 125. The sum of these angles is 540. So 3x plus 330 is equal to 540. Subtract 330 from both sides, we are left with 3x equals 210, and if I divide both sides by 3, x is 70, which means the size of the angle BCD is 2 times by the 70, which is 140. So we've got 140 degrees. Question number 27. Triangle ABC and triangle DEF are similar, and what we have to do is work out the length of DF. Well, what we can do is recognize that AB corresponds with DE, and with this we can find out the length scale factor. So we've got 12.6 divided by 8.4 being our length scale factor. 12.6 divided by 8.4, as the decimal is 1.5. So we have 1.5 for the length scale factor, and therefore to find out the length of DF, well, AC corresponds with DF, so therefore DF is equal to 6.4, and then we multiply this by 1.5, and it turns out we would get 9.6 centimeters. So we have 9.6 centimeters, and then we have to work out the length of CB. Well, we've got this 15, the length FE, which corresponds to CB. So to find out what CB is, we would have to do 15 and then divided by 1.5, which is 10. So we have 10 centimeters. Question number 28. We have to make g the subject of the formula t equals the square root of g plus 6 over 2. Well, if we square both sides, we will end up with t squared equals g plus 6 over 2. And now if I multiply both sides by 2, we are left with 2t squared equals g plus 6. We want to get g by itself, so now if we subtract 6 from both sides, we will be left with g equals 2t squared subtract 6. So we've got g equals 2t squared subtract 6.